Hello students, welcome to Engineers Academy. In this video we are going to solve this problem which says that determine the angle between the cable AB and AC. So we have these two cables AB and AC. So let's say that we define a position vector from A to B. Let's say this is my position vector from A to B, and let's say that we define one another position vector from A to C. So this is the position vector from A to C. So using the dot product, we can find the angle between both of these cables, right? So if I take the dot product of these two position vectors, RAB dot RAC, so this will be equal to the magnitude of RAB and the magnitude of RAC cos of theta. And from this we can say that cos of theta is equal to RAB, the position vector, dot product with the RAC, the position vector, divided by their corresponding magnitudes, the product of the corresponding magnitudes. So now to solve this problem, we need to find the position vector from A to B and the position vector from A to C. So the position vector from A to B, we can find it by traveling from point A along the x, y and z axes until we reach that point B. So to reach that point B from A, we need to move 6 meter distance in the negative x direction. So I will write that minus 6 in the 6 meters in the negative I. Then we need to move 1 meter distance in the negative j direction or in the negative y direction. So I will write minus j, and we will reach here. So once we reach here, then we need to move 2 meters distance in the positive k. So plus 2k. So this is the position vector from A to B, and we can find its magnitude. So its magnitude will be, we need to take the squares of each and every component and then take, we will take the square root to find the magnitude of this RAB. Let me write it here. So this RAB magnitude will be equal to 6 square plus 1 square plus 2 square. While taking the square, the minus doesn't matter, right? So minus 6 square or 6 square will have that same answer. So this is the magnitude of the position vector from A to B. So 6 square plus 1 square is 1 and 2 square is 4. So this is square root 41. So this is, let me write it is square root 41. And this will be in meters, remember. Now we can find the position vector from A to C in using the same method. So now to reach that point C from A, again we need to travel 6 meters in the negative I. So I will write minus 6. Then we need to travel this much distance in the positive j, and this distance is 1 meter. So I will write plus j. And then 3 meters distance in the positive k. So I will write plus 3k. And its magnitude will be, so again we can take the square, 6 square plus 1 square plus 3 square, and then take the square root 6 square plus 1 square plus 3 square. So this is square root 46, square root 46 meters. Now we can use this equation. This is our initial equation. So cos of theta is equal to RAB, and RAB is minus 6i minus j plus 2k, and dot product with minus 6i plus j plus 3k divided by the magnitude of RAB, square root 41 multiplied by square root 46. So now we can take the dot product. So since it's a dot product, so we need to multiply I with I, j with j, and k with k. So this is minus 6 into minus 6. So this is 36. I dot I is 1, and minus 1 into plus 1. So this is minus 1. J dot j is 1, and 2 into 3 is 6. So this is, and plus into plus is plus. this is 6 divided by square root 41 multiplied by square root 46. So 36 minus 1 plus 6 divided by square root 41 multiplied by square root 46. This gives us 0.944. So cos of theta is equal to 0.944, and if we take cos inverse, then we will be able to find that theta. So now if I take the inverse of the answer, cos inverse answer, that is 19.25 degrees. So theta between both of the cables is 19.25 degrees. Let's solve this problem from engineering statics. Again, the problem says that determine the magnitude of the projected components of force F acting along the cable BA. So we are given this force F, and this is that Cartesian vector, and we are required to determine the magnitude of the projection of this given force along this BA cable. So we can find that projection by applying the dot product. So we can say that the projection of the F force along BA magnitude, this will be equal to that force F and the dot product with the unit vector from B to A. So we need to find this unit vector from B to A. So as we know that the unit vector from B to A is equal to the position vector from B to A divided by its magnitude. So we can find the position vector from B to A. So what we can do, we need to travel along x, y and z axes to reach that point A from point B. So that will be our position vector. So to reach that point A from B, we need to travel 2 meters distance in the negative k. So I will write minus 2k. Then we need to travel 1 meter distance in the positive j. So this 1 meter distance in the positive j. And then 6 meter distance in the positive I direction, that is in the positive x. So I will write 6I. And we can find its magnitude. Its magnitude will be 6 square plus 1 square plus 2 square under the square root. 6 square plus 1 square plus 2 square. So this is square root 41. So the magnitude is square root 41. So we can put that in this equation. So that will give us the projection of that given force along BA magnitude, and the F vector is given. So F vector is 400I minus 200J plus 500K, and dot product with this unit vector from B to A. So this is 6I plus J minus 2K and divided by square root 41. So since it's the dot product, we need to multiply I with I, J with J and K with K. So 400 into 6 is 2400. I dot I is 1. Minus 200 into plus 1 is minus 200. And 500 into minus 2 is minus 1000. And K dot K is 1. So divided by square root 41. So 2400 minus 200 minus 1000 divided by square root 41. This is 187.41. 187.41 Newton is the magnitude of the projection of that force F along BA.